Radians versus degrees. Sunday, Sunday, Sunday. It's the ultimate showdown. Why do we even need radians? Why are they used sometimes instead of degrees? We're gonna find out. I'm gonna teach the whole lesson like this. No, I'm not. That's not gonna work too well. So what are radians? Radians obviously are another way of measuring angles. You've seen it before when you go to your calculator and you press mode. You can go radians or degrees. Actually, for this lesson, it doesn't matter what you're set in. It's a good idea to leave it in degrees generally. However, for this lesson, it doesn't matter. So you don't have to be switching back and forth. Don't panic about that. But because you've always wondered, I'm going to tell you. What are radians? Radians are, I'm going to use complete sentences here. Radians, well, radians is a way to, that sounds like bad grammar, but I really don't think it is, to measure angles based on the circumference of the unit circle. Okay, let me translate that into English for you. Instead of using degrees, a lot of times people use radians. And what it is based on the circumference of this circle right here. That's a beautiful little circle. We'll give it a radius of 1. 1 what? It looks like Pac-Man with his mouth closed. 1 meter, 1 inch, 1 centimeter, 1 unit of whatever. And yeah, pardon my little smudge here on the circle that kind of pushed him in the back of his neck. There we go. Straighten him out. Make him a little rounder. Anyway, you have this circle with a radius of 1 unit, whatever it is. And if I wanted to know the circumference of that circle, I would use the formula 2 times pi times the radius, which in this case is 2 times pi times 1, which is completely pointless to write because it's just 1. So the circumference of this circle, of this unit circle, is 2 pi. So 2 pi is the distance around this. So if this was a mile, if I had a 1 mile radius, then I would have 2 pi miles all the way around it. So if I drew a circle that was a mile with a radius of a mile, then I would have to drive all the way around it, and it would take me at 6.28-ish. It would be 2 times pi. It would be that many miles all the way around. So why do we use it? And this is going to be a really wordy answer potentially. But in physics, chemistry, a little bit, mostly physics, and a lot of other things in higher level mathematics like calculus, which is used of course in engineering and architecture, things along those lines, and engineering of really tiny things like your cell phone, your iPad, electronics, stuff like that. Anyway, in calculus and in a lot of those things, it's used in a ton of areas. They use radians more than degrees because it's called the phantom unit, meaning this. Here goes, I'm going to try to make this clear. It cancels out. You know, if you had feet per second, your unit would be feet divided by second. It'd be feet per second. But if you have radians, you don't have to worry about the units because radians is automatically a unit that cancels out. It is the distance around divided by the length of the radius, and because it's distance divided by distance, distance cancels and it leaves you with simply a number, and we call it radians. If that didn't make sense, it's okay. Take a physics class, it will make sense. But anyway, that's what radians are. Let me point out something here that's going to come in handy. This entire circle, all the way around it, is 2 pi radians. Well, how many degrees is a complete circle? Yeah, 360. So I'm going to make a tiny little chart over here on the side that's going to come in handy. It's going to be just some of the more basic ones that are used very frequently. So I'm going to start with something like degrees on this side, and I'm going to put radians on this side. And these are going to be some of the very common basic ones. And I have 1, 2, 3, 4, 5 spaces, and I'm going to put the one I just put. If we had 360 degrees, complete circle, that would be 2 pi radians. And I'm going to put one that's really obvious and basic. If I have a circle that is completely closed, then it is 0 degrees. It's also 0 radians. Okay? let's kind of tinker with this idea a little bit here. I'm going to grab a scrap piece of paper and start drawing a little bit. You don't have to draw this, you can just kind of watch. So if I had a half of a circle, that is the crappiest half circle I think I've ever drawn in my life. I would try it again, but I'm not going to waste your time. This is a half circle, take my word for it. How many degrees is this half circle? Yeah, if I opened up this thing completely, it would be 180 degrees. Well, if I drew the whole thing, which is, again, a horrible circle, it's kind of like a Pokemon ball. If I had a half circle, it would be 180. If I did the whole circle, it would be 360, as you know. So if 360 degrees is equivalent to 2 pi, then 180 degrees is equivalent to what? Well, clearly, this is half of that. So half of 2 pi is 1 pi. And don't panic when you see radians and a pi hanging around on it, because it often is. Most of the time it is. So we're going to put this one in the middle. 180 degrees is pi radians, equivalent to pi radians. Now we're going to squeeze 2 more in here. We're going to put a 90-degree angle, and we're going to put a 270-degree angle. Mr. Reader, what's a 270-degree angle look like? What is it, super obtuse? Actually, yes. That's not the technical name for it. But angles are measured on a unit circle, or on a coordinate plane, rather, by starting with this one. You're going to have something like along that line. And then you'll swing and around and go like that, and it goes boom. So there you go. This is the initial side, is what I call it, but this is the terminal side, and it terminates right here, and this is a 90-degree angle. Well, a 270-degree angle would start here, and it would swing all the way around 90 degrees, 180 degrees, and then 90 more, and it would end right here. So the obvious question is, isn't it the same as a 90-degree angle? Actually, yes and no. In terms of like building a house, yes, that's a 90-degree angle. But if we're going to measure how wide like this door swings, well, it swings 270 degrees, and it stops there. Okay, so let's go ahead and find out a couple answers for these. A 90-degree angle would be a fourth of a circle. And I'm going to write out what's happening in my head right now. So I have 1/4 of a circle. And you know what? Yeah, it's 1/4 of a circle, but it's really 1/4 of a complete circle, which is this many radians. So what's a fourth of 2 pi? Don't let the pi bother you. What's a fourth of 2? You have $2 and I say, hey, I want a fourth of that. What do you give me? Well, you probably give me nothing because you don't want to give me any money. But if you did, you would give me half a dollar. You'd give me 50 cents. You have 1/2 pi, more likely to be written as pi divided by 2. These are the same thing. Half a pi and pi divided by 2 is the same thing. This is starting to look kind of wacky, but don't lose me here. All right, this is 3/4 of a circle. 3/4 of a complete circle. 3/4 of 2 pi. Again, don't let the pi bother you. What's 3/4 of 2? You have $2, and I say, hey, can I have 3/4 of that? And what do? Nothing. You don't give it to me. If I wanted 3/4 of your $2 bill, you would give me $1.50. I'm going to write it in the way that no one ever writes it. 1.5 pi. Nobody likes that. We use improper fractions with these. So this is 3/2 pi. Also known as 3 pi over 2. Okay, these are the same thing. Completely the same thing. And if you're wondering why, I'll explain it in about 10 seconds. Okay, real quick, I want to explain why this is. Has it been 10 seconds yet? Alright, probably now it has. Don't rewind the video to time me on that. 3/2 times pi. Oh, pi over 1. See, put it over 1, and you can multiply fractions straight across. 3 times pi, 3 pi. 2 times 1 is 2. Boom, done. That's why these are the same thing. Okay? Well, how do we convert from degrees to radians? We got to multiply by something. We're going to multiply by, okay, let's think about this for a second. If we're going to convert from degrees to radians, then we are going to need a pi, and we're going to turn it, well, we're going to divide it by 180. Let me rephrase this just so it makes a little more sense. How do we turn a 180 into a 1 pi? Well, 180 turns into 1 by dividing by 180, and we put a pi in because we multiplied by pi. Okay, real quick, I want to just kind of show you where that comes from. We'll grab a random green post-it note that happens to be laying on my desk. Here we go. If I have a 180-degree angle and I say, man, I wish I knew how many radians this was, if I multiply by pi over 180, then sure enough, the 180s cancel out and I'm left with pi. Okay? If I want to convert from radians to degrees, I'll do something very similar. I will multiply by, I wonder what I multiply by. Let's go backwards. If I want to turn pi into 180, then I'm going to turn a 1 into a 180. So I'll multiply by 180, but I got to get rid of my pi. So if I have lost you, here's all you need to know right now. To convert from degrees to radians, multiply by that. To convert from radians to degrees, multiply by that. As we do more of these, this will begin to make more sense. So if you're kind of lost about why we wrote what we wrote, don't you panic. Let's just practice. Let me ask a ridiculous question. You know the answer. Is this radians or degrees? Obviously it's degrees. It has the degree symbol on it, so let's deal with it. We are going to convert from degrees to radians or radians to degrees, but this one's from degrees to radians. So we're going to take our 75-degree angle and we are going to multiply it by pi over 180. Let me tell you what not to do. Let me go ahead and do it wrong first. This is not wrong, but nobody ever does it this way. You might get beat up on the playground if you do it this way by big burly mathematicians. Don't do that. Don't do that. Don't be touching that pi in your calculator. No, don't touch the pi. Your grandma baked it for a reason. Oh, thanks. I'm here all week. What I recommend you do instead is this. Let's put that over 1. And we are going to multiply straight across. We have 75 pi divided by 180. And then we reduce our fraction. Just reduce your fraction, just like you've been reducing since you were in elementary school. What number goes into 75 that also goes into 180? Hopefully you're thinking of the number 5. 5 goes into 75 15 times. 5 goes into 180 36 times. Okay? Y'all with me? Boy, I hope so, because we're not quite done. Because what I did actually over on the side, I wrote it down and I realized that's not the smallest it'll reduce. 15 goes into that. I didn't even think about it. 15 goes into 75. It goes in 5 times. Yeah, it's going to work. Kind of looking at it over on the side. You can't see where I'm looking, but I'll tell you in a second. 15 goes into 75 5 times. 15 goes into 180 12 times. There we go. 5 pi over 12 is our answer. Alright, did you get lost? Don't you panic. Here's what happened. Don't have room in the block, so I'll use a post-it note. We just reduced 75 over 180. We're going to put our pi there. And the first time I did it, I said, oh, 5 goes into that. 5 goes into 75. 15 times. Yay. And then I did 5 goes into this 36 times. And then I glanced at that over on the side where I had kind of scribbled it down to make sure I was right as I was doing it. And I kind of scribbled it here. And I said, whoa, wait a minute. Both of these numbers are still divisible by 3. So if you need to go an extra step, you can. We're going to divide both of them by 3. 3 goes into that 5 times. 3 goes into that 12 times. Nothing goes into 5 and 12. That is our final answer. Okay? If you are lost, it's okay. Let's do another. a 335 degree angle. That's a pretty big angle, but what we're going to do is take a 335 degree angle and we're going to convert it to radians. So we multiply by pi over 180 degrees, and we're going to put that over 1. So yeah. In the process of doing this, we have a 335 degree angle times pi. I'm going to mark out that degree symbol. Probably should not be using a pen. Oh well. I have a pencil laying right here, but it doesn't really work too well. And then I start thinking, what goes into 335 that also goes into 180? And it looks like 5 goes into 335. I'm going to resist the urge to use a calculator right now. I know you're reaching for yours, but I'm not going to do it. I'm going to fight the temptation. So 335 over 180. Let's see, 5 goes into 335. Shoot, I don't know. Why am I not using a calculator? Because 67 times. That's an interesting little gadget there, isn't it? The reason I'm not using a calculator is because when we overuse a calculator, we don't learn to think. 67 pi over. Okay, 5 into 180 goes 36 times. There we go. That's it right there. 67 pi over 36. Will the calculator do it? Yes, but I'm not telling you how. You won't get that from me. Alright, I'm going to skip 3, 4, 7, and 8. I'm going to go ahead and hit the degree ones, and then we'll hit the radian ones. Alright, let's keep going. 200 degrees. That's pretty hot. Nearly boiling. By the way, what is the boiling point of water in Fahrenheit? Do you know it? I'm not telling you. You have to look it up. It's one of those things you should just kind of know. It's common knowledge. Alright, we're going to multiply straight across. We have 200 pi divided by 180. When we reduce it, we're just going to keep our pi floating around on the top, but let's reduce it. Let's see, 20 goes into that 10 times, 20 goes into that 9 times. 10 pi over 9, that's how many radians it is. I'm happy, let's move on. 100 pi over 180. You skipped some steps. You're dang right I skipped some steps. We got the hang of this. Okay, I'm going to drag this one out one extra step. I know both of these are divisible by 10. 100 divided by 10 is 10. 180 divided by 10 is 18. Whoa, both of those are even. We're going to reduce. 5 pi over 9. There we go. We're done. We're done with that. Let's hit the rest of them over on this little section right here. And when we do so, it's going to look like this. We are going to, well, I'm going to switch colors actually. Actually, no, I'm going to use a pencil. Find this pencil that's laying on my desk that's so crappy. Maybe it'll work. There we go. 7 pi, can y'all see that okay? Like you could answer me through a video. See, look, the pencil edge is broke. Sorry thing. It broke again. Forget it. Stupid pencil. Let's use an ink pen. I'm going to switch colors though so it doesn't run into that blue and you're like, everything ran together and I couldn't pay attention. Alright, 7 pi over 8. And we're going to multiply by 180 over pi. Now, don't panic on this one. 180 over pi. And it does look ridiculous. But let me tell you the easy part of it. The whole point for this is the pi's are going to cancel. And we should reduce 8 into 180. Well, 8 doesn't go into 180. But, let's see. 4 goes into both of them. It goes in 45 times. And that goes in twice, and we end up with 7 times 45 divided by 2. I am going to cheat on this one. 7 times 45 divided by 2, and sure enough, 157.5. That's how many degrees it is. If you got lost in the process, here's what happened. We had 7/8. We multiplied by 180. Mr. Reader, you didn't type your pi's in. Nope, didn't, because they're going to cancel out anyway. So we ended up with 157.5. For the rest of these, I'm going to just use the calculator because these we can really get bogged down with these if we don't. Just for the sake of moving on, let's do it. So we have 3 pi over 4. We're going to multiply by 180 over pi because these are radians, so we're converting it to degrees. We're going to cancel out our pi's, and then we go, well, 3, random pencil edges. Rolled across my paper. You couldn't see it, but it was there. Stupid pencil. 3 times 180 divided by 4. 135. Basically 3/4 of 180, and we end up with a 135-degree angle. These go real fast. We have 5 pi. We're going to multiply it by 180 over pi. Notice that I kind of floated him up because we're going to put a 1 under there, just in case you need to. Cross out your pi's. 5 times 180 is 900. Not even going to use a calculator for that one. Don't need to. 900 degrees. 2 pi over 3 times 180 over pi. At this point, you pretty much got it. 2 times 180 is 360. 360 divided by 3 is 120 degrees. We are done with that first part right there. You happy? Boy, I hope so. All right, coterminal angles. Well, what are coterminal angles? I don't know. Let's talk about it real quick. This part will not take too long at all, and we'll do the 12 problems at the bottom. And then the back side of this is up to you, and it's basically exactly what we're doing on the front. As ridiculous as this looks, it's going to help us when we get into some other more practical things that involve, don't panic when I say this, but word problems. Because life is full of word problems. No one's going to walk up to you on the street and be like, hey, find the coterminal angle. So they're going to instead give you a real-world scenario, which is the way math is supposed to be, because math explains a lot of things in the world. Okay, enough rambling. Post-it note time. You don't have to draw this. You can just kind of watch. I have an angle. I have an angle. I have an angle. Hey, 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 hey. We're going to draw it right here. We're going to draw it on the coordinate plane. So it started, let's put it, make it red. I'm going to make it a 45-degree angle. We'll pretend like that's a 45-degree angle. And I was like, oh man, my angle, it was 45 degrees, right? Yeah, I'm so happy. I had a door that opened 45 degrees. Well, let's suppose my door hinge is crazy and insane. It is off the hinge. I said off the chain, but you don't hang doors on chains. Let's suppose my door also swings 360 degrees and then 45 more. Does it end up at the same place? I mean, there's an obvious answer based on my picture. I could open my door 45 degrees, or I could somehow swing it all the way around 360 and 45 more. So I have a 45-degree angle, and I also have an angle that is 360 degrees, but then it kept on going 45 degrees, and I end up with a 405-degree angle. Is that even possible? Yes. It is. When you swing around your circle more than once, then you are going to end up, if it's right, in the same place you started with. So a 45-degree angle is equivalent to a 405-degree angle, which is also equivalent to a, watch this, it's about to get cool. It's also equivalent to a, add 360 again, a 765-degree angle, which is equivalent to a 1,125-degree angle, which is equivalent to a 1,485-degree angle. You get my drift, okay? All these angles are the same, because every time I'm just adding a circle. We just swung it around one more time, but it ended up in the exact same spot. Alright, now I could have started with a 45-degree angle and been like, well, maybe my door swings in a clockwise manner, and I can subtract a full circle, and a negative angle can be the same as that one. Yes, you can have a negative angle. It just means instead of opening like this, it opens like this. Instead of going clockwise, it goes counterclockwise. So my arrow would instead go this way. All right? That's a negative angle going clockwise. Positive angles go counterclockwise. Negative angles go clockwise. All right, enough of that. Coterminal angles are angles that have the same terminating same terminal ray. My goodness, what are you talking about, Ray? Who's Ray? Ray is short for Raymond, and everybody loves him. No, a ray would be like this guy right here. You know, like in geometry, you studied a ray, which has an endpoint and it goes on forever in the other direction. But it has the same terminating ray, or terminating segment, if it doesn't have an arrow at the end. But it basically ends in the same place. That's what it really means. And we get that by adding 360 or subtracting 360. All right, so let's think about it. These are in radians. We're going to tackle those later. We're going to go ahead and get these first. All right. Name the coterminal angle between 0 and 360 degrees. For degrees. Well, so these are degrees. So did this door open more than one full circle? Yes. This number that I'm pointing to right now is more than 360 degrees. If I was playing basketball and somehow had the skills to do more than a 360, but I could do a 425, I would have spun around one entire circle and then a little bit more. So the question is, how much is that little bit more? And I'm going to write down what happens in your head or in your calculator. Hopefully this one can happen in your head. This angle is too big. You way too big, angle. There you go. That's it. 425 degrees minus 360 is going to give me a 65 degree angle. That angle and that angle are the same. They put you in the same place. You don't have to draw what I'm drawing, but here goes. A 65 degree angle starts here and it opens up to about there. It goes whoop. There's your little arrow and it opens up. A 425 degree angle starts here and it goes whoop and it ends up in the exact same place. It just goes around one extra time, but it ends up with the exact same place, same position. Okay, a negative 330 degree angle, let me ask a ridiculous question. Is negative 330 in between 0 and 360? No, it's not. It's way too small. Knowing that it's too small, instead of it spinning counterclockwise, the opposite direction a clock runs, y'all just glanced up at the clock, didn't you, to see which direction a clock runs? Instead of it running in a positive direction, it actually ran in a negative direction. It ran clockwise, the direction a clock runs, the way my finger is running right now. Okay, so here is the deal. This number is too small. If it's too small, then we need to add 360 degrees. A negative 330 degree angle plus a 360 degree angle will put us in the same position as a 30 degree angle. There we go. Real quick, I'm going to draw this before we move on. A 30 degree angle is obviously about here. Opens up 30 degrees. A negative 330 degree angle starts here and goes this way 330 degrees and it ends up here. These are the same angle. They just took different paths to get there. Alright, real quick, we're going to go through these four, then we'll hit the radians, and I'm going to let y'all work on the back. Lucky you. Here goes. Negative 19. Too big or too small? It's not between 0 and 360. Because it's not between 0 and 360, it's either too big or too small. Therefore, because it is too small, we should add in order to reach what we need. Here's the shortcut. I'm not going to write it down. You can do this, or you can just kind of gather it together in your mind. If it's too small, you need to add 360 until you get there. If it's too big, you need to subtract 360 until you get there. Get where? Get between these two numbers. Because in between these two numbers is one beautiful, perfect, lovely angle that doesn't swing around way too many times. Alright. Negative 19 plus 360 is 341 degrees. There we go. Not going to draw it. I'm going to move on. Too big or too small? Too small. Because it's too small meaning it's below 0, we need to add 360 in order to get there. So we're going to add 360. When we add 360, we end up with 315 degrees. Okay, the next two are crazy. This one always messes people up. It's been messing people up since the 80s when people tried to call Jenny Look at the numbers. Think of the song. You'll get it. All right, number 17 though. Too big or too small? Too big. Okay, if I was to draw a 3,625 degree angle, I would go around and 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 around several times before I landed somewhere. So this is clearly too big. So let me write down something that's sort of pointless, but we're going to do it anyway. I'm going to subtract 360, and I'm just going to do it in the calculator to prove a point. 3625 minus 360. Oh, there we go. There's my final answer. No. No, 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 no. This is not your final answer. No, 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 no. Because that number is not less than a circle. Name the coterminal angle between 0 and 360. That is not between 0 and 360. It's still too big. So I'm going to subtract 360 again. Oh, that's still too big. I'll subtract 360 again and again and again. And I'm going to keep doing this until I get an answer that is between 0 and 360. So the answer is 25 degrees. And I actually, in case you care, I had to subtract 10 of them, and it gave me a 25 degree angle. Okay? How did I know there were 10 of them? Trust me, there were 10 of them. Because it's 3,600 plus 25. I mean, you can kind of look at the number. This one's more difficult. Jenny said so. Who's Jenny? Look it up. Not right now. Look it up later. 8675309 minus 360 is, oh man, that's too big. Minus 360, that's too big. And by the way, this is going to take me all day. This is going to be a very long video if I continue this pattern, so I'm not going to do it. Not that way. 8675309 is a huge angle that's clearly too big. I'm going to divide it by 360. If I was to keep hitting enter like I was, I would have to hit enter 24,098 times in order to get where I wanted to go. Here's where I want to go. 8675309 minus 24,098. What about the decimal? Forget the decimal, that's the whole point. Times 360. When I subtract 360 that many times, I end up with a 29 degree angle. 29 degrees. Yeah. Alright, 6 more problems. Let's go through this very quickly, although the idea is slightly different. These are in radians. Wow, that changes things a little bit, doesn't it? Because this is in radians, we're going to aim for something between 0 and 2 pi. Alright? Since we're aiming for something between 0 and 2 pi, I need to decide if it's too big or too small, first of all. So, negative 7/3. Let's ignore the pi for a second. And here's the question in my mind. Is negative 7/3 less than 0 or greater than 2? It's less than 0. This one is too small. On these, I had to add or subtract 360. On these, I'm going to add or subtract 2 pi. Negative 7/3 pi plus 2 pi. I know I said to ignore the pi, but I really meant that in terms of the calculator. Negative 7/3 plus 2. Now, I would like to think that you know what this is. It's negative 1/3. Okay, and don't act like you've never seen that decimal. It's negative 1/3, all right? This is negative 1/3. This is negative 1 pi over 3. Is this too big or too small, or is it just right? This is not between 0 and 2. So we need to take our negative 1/3, whoops, and we need to add 2 to it again. I'm not going to deal with the pi in the calculator. That complicates life. Don't go there. You get crazy decimals, you won't know what to do with them. 1.6 repeating. 1.6 repeating is 1 2/3. That is 5/3. This is 5 pi over 3. Here's what just happened. Let me show you again. I'm going to do this real fast. Negative 7/3, turn it into a fraction, is, oops, my bad. Negative 7/3, was too small. I added 2. Negative 1/3. Still too small. I add 2 again. We'll turn it into a fraction. There it is. 5/3 is between 0 and 2. We're done. Let's do one more and then do 4 more. Haha. 7/3 pi. Is that too big or too small? Or is it just right? It's too big. 7/3 is bigger than 2. That's 2.3 repeating. It's 2 1/3. So because it is too big, we need to subtract 2. Put it over 1 just for fun, but here we go. 7/3 minus 2. I'm not even going to use my calculator. 2 1/3 minus 2 is the third. Now I'm flying through some of this fraction stuff because I'm going to treat you like you know what you're doing and elementary school was kind to you with fractions, okay? Because y'all ain't stupid. You got this. Negative pi over 3. That's too small. It is not between 0 and 2 pi. It's on the lower end. So we're going to have to add in order to get it in between. So we're going to add 2 pi. If you want to get technical, we actually just did it right here. So you know the answer, but let's do it anyway. Negative 1/3 plus 2 gives me 2 minus 1/3. 6/3 minus 1/3 is 5/3. Okay? Too big, too small, just right. Too small. Too small. It's below 0. Negative 5 pi over 6 plus 2 pi over 1. I'm not going to use a calculator on this. Don't feel like it. We're going to add 2 to negative 5 over 6. We're going to take 2 and subtract 5 over 6. It's going to leave us 1 and 1/6. This is in my head right now. 1 and 1/6. That is the same as 7/6. There was a pi. Alright, 2 more. Too big, too small, just right. Too big. 9 over 4 is more than 2. So we're going to need to subtract. If this was a number line right here, and there was 0 and there was 2 pi, then 9 pi over 4 is too far over this way and we'd have to subtract to go back. Yeah, that rhymed. Subtract to go back. We will subtract 2, put it over 1. I don't know why, I just feel like doing that. Alright, 9 pi over 4, that's 2 1/4 minus 2 leaves me 1/4. I have 25 cents. You can leave that 1 off there. Okay, one more. Lucky you. Negative 9 pi over 4 plus, oh, it's too small, so we're going to add 2 pi. Make that look more like a pie. I'm a terrible baker. Haha. Alright, negative 9 pi over 4 plus 2. Negative 2 1/4 plus 2 leaves me, well, leaves me out 1/4. Man, that's still too small. That upsets me. So we're going to add 2 pi to that. Add 2 pi to that, and we end up with, shoot, I don't know, and I ain't telling you. No, I'm kidding. I do know. 2 minus 1/4 gives me 1 3/4. 1 3/4 is the equivalent of, I'm going to run out of the little boxes here, but I'll get over it. That gives me 7 pi over 4. There's my final answer. Again, the back side is up to you. It's going to go quick. It's very self-explanatory. It's exactly what we did on the front. Don't look at the number of the problems and panic and say, it's way too many. You've got this. You'll fly through it really quickly. All right.